So what I wanted to talk about tonight is basically the approach we are having for AI beyond algorithms. And so this is not the title of my presentation. This is our Thales Group motto. But basically, what I want to talk about is saying that AI is not only about algorithms. But yeah, first, I need to make a very quick intro to Thales, so the company, the group I belong to, in order to understand the context in which we apply AI. So Thales, we're a French multinational company. It's 80,000+ employees in 68 countries around the world, and including Canada, obviously. And our mission is to help our customers master every decisive moment. Now, our customers, they operate in very diverse environments. So from the bottom of the oceans to the depths of space and cyberspace. They are, and therefore we are also active in 5 areas, which are defense and security, digital identity and security, ground transportation, space, and aerospace. And those customers, they are governments, institutions, cities, or private companies. So we have basically decades of experience in those areas. And we have developed, and we're still actually developing, an extensive portfolio of technologies focused on addressing what we call the critical decision chain. So from the sensor to the command and control center, basically we capture data, we process it into information, knowledge. Ultimately, we try to deliver decision support and recommendations. All right. So now in that context, it appears that basically we cannot approach AI solely from the algorithmic standpoint. Okay, and for us, AI is definitely not only algorithms. Within Thales, oops, this slide doesn't look like it should. Anyway, hope you can read it. Within Thales, I'm part of an entity which is called Thales Digital Solutions, and we serve our business units and some of our customers directly by being basically at the forefront of those new digital technologies, including AI. And there are 2 things that are very important in this slide, and that I really want to highlight, even though it's pretty small. The first is that, so to us, AI is a complex system. So therefore, we approach AI, okay, from the algorithmic standpoint, but also from the system perspective. And the other thing that is important is that AI should be human-centered. And in Thales Digital Solutions and in Thales, generally speaking, we are talking about augmented intelligence. And what we want to do is basically augment the capabilities of human operators, human beings, those guys who are in charge of the complex systems that we are deploying, thanks to AI. So obviously, we are working on those what I call traditional AI, so which usually people relate to machine learning. It's actually quite amazing. I did quite a number of presentation and introduction to AI within my company and outside of my company. And usually I ask my presentation asking, so what is AI to you? And it's quite amazing how often I hear AI is algorithms. So yeah, indeed, algorithms is a very important component of AI, and we are working on those. We are working on those with a focus on, well, explainable and robust AI. Same as the previous presenter, Maria. We don't want to deliver black boxes to our customers. We want to make sure that they understand what's happening inside and what is why the system recommends a decision the way it is recommended. Okay, but we are also working on other techniques or technologies. So reinforcement learning is one of them. Reasoning engines, knowledge representation, and so on. So we are working on those, but not only. And this is where I will try to introduce a few of the different technologies that we are working on, and why I relate it to AI. So AI is a big buzzword. Digital twin is another one, but we are working on this concept or this technique. Digital twin for us, it's so perception beyond sensing. It provides situation awareness, so basically a virtual representation and understanding of the current situation that the system or the AI agent is facing. And it's based on the sensor data that the system is capturing, on the data that are shared with this AI agent or this system by other systems, for example. And it's also based on simulation models. So basically trying to enhance the data that we capture or the data that we lack in order to be able to have a more complete situation awareness. For us, digital twin is also offering anticipation and what if scenario exploration. So basically, we're trying to forecast how the current situation may evolve in the near future, depending on what we call what if scenarios of interest. So basically, from an instant in time, we're trying to have our system explore what if this or that happens. How will it affect the situation, and how will it affect the decisions that I, the operator, may take in the near future, and how my decisions may affect the outcome. So basically, this digital twin is a real enabler for decision support and to optimize the decisions that an operator may want to take. But also, it's a real enabler for an AI agent. So basically, artificial intelligence that is trying to support a human being. Obviously, digital twin is has the potential of creating a massive amount of data. So it's not like we already have a lot of data thanks to all the sensors we have deployed in the environment, and within our systems we are creating even more. And obviously, AI can help us deal with this vast amount of data to try and come up with the right decisions. Now another component that we are working on, a piece of technology that we are working on, is on the human being. So as I was saying, we want to develop AI that is human-centered. And the next two slides are presenting two pieces of technology that we are developing here in Canada in Thales Digital Solutions. The first one, we coined it cognitive shadow. So basically, the aim is to try and capture the human's cognitive patterns or the decision pattern that a human operator may have with respect to different situations. Okay, so basically, what we want to do is to train the system, to train the cognitive shadow, to recognize the behavior pattern of this human operator with respect to specific contexts. So basically, to try and see, okay, given this and that context, the decision that usually the expert, this human being, is taking is A, B, or C. Okay, and we will try to train this cognitive shadow in an environment or in conditions where this expert is well rested, he's not tired, he's not under stress, and so on, so that we really capture his expertise on how to deal with this situation. And where we want to use it is basically for decision support. We want to have this cognitive shadow help the operator when this operator is under stress or is tired. And we want to have cognitive shadow being able to notify when the operator is deviating from their pattern. All right. But beyond that, what we see here is actually the possibility to enhance the synergy that we try to create between human and AI agents. Okay, and what we think is that we could embed this cognitive shadow within an AI agent that is training with a human or a group of human operators. And this AI agent will be able to learn the behavior model of those humans in order to be able to assess, recommend, and even, why not, anticipate the decision of those human operators when they are deployed together on a specific mission. And typical use case that we can have for cognitive shadow is air traffic controllers, for example. Those guys are under high stress, usually can be very tired because they have long shifts, and we want to be able to have an AI that is capable of dialoguing with this air traffic controller to help him take the right decision at the right moment, and identify also when this guy becomes too tired to take the right decision. Right? Another piece of technology that we are working on to have human-centered AI is basically to capture the human's physical state, is human sensing. So we're trying to capture the biodata, the biophysical data of a human being, to try and see how available this guy is, and what's his physical state. So we can use a variety of data sources, and depending on the context and depending on the domain, there is more or less of information that can be captured. Typically, eye tracking is usually not too invasive. ECG can be pretty invasive. So, for example, in the military domain, we can capture more data. In the civilian domain, it can be more difficult. And basically, what we want to try and infer is whether this human being that the AI agent is working with, or the system is working with, is he available or not? Is he stressed? Is he tired? What's his mental load? Is he having tunnel vision, hypoxia, disorientation, etc.? And similar to cognitive shadow, what we see is that we can integrate this human sensing capability within AI agents. So basically, give the AI agent access to those data that are being captured, so that it's aware of the level of availability of the human being, so that it can adapt its behavior to this level of availability. Yeah. So I won't go through all the different technologies that we're working on, but basically what we're trying to do, so as I said, AI is a complex system, and what we're trying to do is to integrate all those different technologies, concepts within one AI agent concept. Let's call it like that, for the lack of a better word. And what we're trying to do is basically to move towards basically an AI agent that can exhibit artificial general intelligence capabilities, specialized for here collaborative platforms. And why collaborative platforms? Well, it's a bit selfish. I didn't introduce myself, but I'm in charge of the collaborative platform domain. What is collaborative platforms? Collaborative platforms is basically a domain whereby we have autonomous platforms, robots, C2s, and so on, that collaborate with human beings to perform a mission. Okay, so for example, in the cockpit of an aircraft, the commander and the co-pilot are working together with the plane to fly passengers from point A to point B. And this can be seen as collaborative platforms. We can see drone operations as also collaborative platforms. So you have drones flying in the sky with human operators on the ground to control them and to perform a specific mission. It can be inspection of critical infrastructure and so on. And what we try to do is basically to propose a standardized AI agent, so basically a framework of AI agent that can adapt to any collaborative platform use case and to all our customers and end users. And we don't want basically to fumble each time with new algorithms, or to fumble with the digital twin, or to fumble with the simulation and so on. We want to have this all integrated so that we can deploy it and make it available to all our customers and end users. And so digital twin is one of the techniques that we're injecting in those AI agents. Cognitive shadow, human sensing, I mentioned. There are others. They are listed here. And one thing that I didn't put in my slides, but you can infer from the first slide on machine learning that I put in, is that these AI agents, they also have a family of algorithms that are available there, and that they can choose depending on the context to use or not, and from which they can, decide, take the decisions based on the outcome of those algorithms.
Akshay has asked, for explainable AI, are you focusing on agnostic models? What kind of techniques and methods are usually considered in industry when we think of explainable AI?
All right. That's a tough one because it's not my field. I have a colleague who is a specialist of it. I'm not too sure how I can answer to that question without making a fool of myself. We are not focused on a specific technique, and we are not focused on a specific methods. At the moment, my belief is that explainable AI and reinforcement learning and all those techniques they are pretty nascent, I would say. And we don't know actually, we haven't explored the whole potential of all those techniques and methods. And so I'm part of the research and technology group, which is basically working at a lower level of maturity of the technologies. And our goal is to explore which techniques or which methods can be the best for what we're doing. So at the moment, I don't know which one is the best. I know that my colleague is exploring uh, counterfactual explanation or something like that. So basically exposing the AI to counter explanation to to counterfacts to see when it will switch from one decision to another. I know this is one of them. I know also that in explainable AI we are working both on the content and how to deliver that content, because I mean my belief is that in explainable AI it's you generate explanations. For example, in RL, you can generate an explanation at each time step that the AI is taking a decision, but you don't want to give the explanation at each time step. So basically, it's how also you deliver this information to the operator so that it makes sense to him or her, and so that it can think about it.
Very good. Thank you for that.
I hope. Yeah. Sorry. Actually, I hope this answers a bit your question.
Yeah, no, I think that does. Jumping to Philip now. Philip's asked, do you think that you will be able to transfer learning between different use cases? Have you been able to do this?
Excellent question, Philip. Thank you very much for asking that one. Yes, as long as the different use cases are not too different from each other. So collaborative platforms, once again, it can be pretty wide, but what we are trying to focus on are use cases that are pretty similar to each other. I can give you a few examples. One use case that we're working on is counter UAV. So basically, you know that an airport, for example, is a very sensitive area, a very critical infrastructure, and we don't want to have drones come and penetrate this airspace. And what we're trying to do is deploy a system where our own drones, so basically our fleet of drones, blue drones, are trying to protect this airspace in order to defend this airspace, in order to prevent red drones to invade it. Okay, so that's an example, and we have a fleet of blue drones with human operators in the control. Another use case that we have, it's with the Department of National Defense. It's on maritime surveillance. So you may know or not, but the waters around Canada are Canada's territory, and we don't want to have any foreign submarine entering these waters without our permission. And what we're trying to do is basically deploy a fleet of underwater drones to monitor those remote areas autonomously, without having the need to have a frigate or another kind of vessel deployed in those remote areas, which it's pretty boring and usually it's pretty cool. And so these two use cases, for example, we see them as pretty similar because in the end, it's autonomous vehicles, unmanned vehicles, deployed with the control of human beings back in a C2 or in a control center. And we think that learning how to approach a target, for example, as air vehicles, so the techniques or the tactics to approach those vehicles could be reused, could be transferred to underwater drones. But if you take use cases that are too different, I think it would take some steps. It's a bit like a human being. Huh? Human beings, we can adapt to different things as long as it's not too far from our knowledge. But when it's completely new, maybe we need to go back to university first.
Very good. That was a very, very thorough answer. We got Wilco. He has asked, are you building safety brakes or kill switches in your agents and software so autonomous behavior of the agents can be limited when necessary?
So, excellent question, Wilco. Thank you very much for asking that one, because as defense industry. We are working in the defense domain. It's a question we very often have, and we are actually very concerned about this. The best safety switch that we have at the moment is the human being. So the agents that we are creating, the software, the AIs that we are creating, they don't make decisions, they recommend decisions. Then it's up to a human being to take that decision or to implement that decision or not. And it's our strong belief that the human beings should always be in the loop, whether be it for, I would say, civilian domains, which also are critical systems. Take a simple example: we are working for the Toronto Metro, for example. Okay, we cannot afford to have a train go haywire with loads of passengers. Okay, but in the defense domain, it's also the case. And in all those contexts, we always have the human in the loop, and we always have the human on the loop. So basically, really, he's the one who can decide whether or not to implement the decision, and he can switch off the whole thing. And in order to do that, we also have to make sure that what the AI is doing, the human being can understand it. And that's also why there is a strong, very important effort onto explainable AI. But more importantly, the strategy of Thales towards AI is true AI, and true stands for transparent, understandable, and ethical.